you see is that if you look at the notes that I gave you on air pollution, there's actually this document in it as well. So if you go the truck, right, you have that one in your notes. Then you also have up underneath it a comparison charts between global warming and climate change. And the first one says, or global warming, climate change, and the other one says ozone depletion. So we're going to, first thing, since it's fresh in our minds, is talk a little bit about global warming and climate change before we move on. All right, so the first thing that we need to talk about is the fact that this involves cause, effect, and consequences. So I've said this several times, but I hope you can kind of grasp exactly what we're talking about. So cause, effect, and consequences. Okay, so what are our causes? The cause, obviously, hopefully, with global warming is greenhouse gases, right? So that is the cause here. Greenhouse gases, gases. And what are they doing? They're trapping heat. Now, that's the cause right there. So there we have our cause. What is the effect? What is the effect? Well, the effect is that it causes global warming. Now, there's some confusion about global warming because everybody thinks that this means it all warms equally, but it is not an equal warming. Some places are going to warm faster than others. And do you have, Nathan, did you find it?
Yeah, the completed notes.
Yeah, but there's some blank notes as well. So, okay, whatever you want to do. Okay, so global warming, it is, although the whole entire planet as a whole is warming up, the warming is not an equal thing. Some places are warming faster than others. The Arctic is actually warming faster than other parts of the planet. And so what this means is that sometimes we don't see the effects right away in whatever part of the world we're living in, but eventually we're all going to kind of catch up to each other in terms of how much warming is going on. So global warming then is the effect. It's warming the planet as a whole. All right, and then what are the consequences? The consequence is actually climate changing. So these are not necessarily interchangeable with each other. It actually is one thing leading to another. So climate change then becomes the consequence. Now, what that means is that every change that occurs in climate is going to be different depending on where you are in the world. So just like the warming is different, so is the change itself. Okay. Let's first thing we want to do is look down here at the little globe we have at the bottom. And we have to first talk about the layer of the atmosphere in which this occurs. Which layer is it? What is it? It's the troposphere. All right, so it's this first layer that this is happening. All right, it's the troposphere. So within the troposphere, so we have the layer of atmosphere that this is occurring in is the troposphere. We also want to talk about what kinds of radiation are affecting this. So which form of radiation is it? We have a rays coming out from the sun. What's getting trapped? Which one? Everybody remember? It's not UV. In this particular, with global warming, the one that's being trapped is infrared, right? So if you look on the spectrum, infrared is the one that causes heat. So that's the one that's being held in and trapped. All right, so the troposphere with infrared radiation. And that's kind of redundant, so I'll just say IR for that one. Okay. Everybody got that so far? Okay, so on the causes and sources, we know that there are several, and a lot of it depends upon which kind of gas we're talking about, as to whether or not which kind of chemical it is. So I'm going to go through each one of these, and we're going to look at the majority of whatever it is that's being there. All right, so the number one gas is carbon dioxide. So we're going to combine these two together. So CO2 is our number one gas. This is the chemical that's involved. All right, CO2, it's the majority leader, right? You looked at the pie chart that the EPA had, and CO2 is the number one gas. This is why it's the most important one, simply because there's more of it than the other gases that are out there. Is it the most potent? No, it's not. However, there's just a lot of it. So where does CO2 come from? What is its source? What's the main one? It's the burning of fossil fuels. Okay, so the fossil fuels are coal, oil, and gas. So what we've done is we reached down into the sink and we pulled it up and put it into another sink, which is the atmosphere. So CO2 is the number one greenhouse gas simply because there's so much of it. All right, and the source of it is burning of fossil fuels. All right, what's another one? Another one is methane gas. Now, we talked a little bit before about the differences between natural sources of gases and in air pollution and anthropogenic. So in some ways, we could go back and talk about CO2 as well as having natural sources, because there are natural sources for it. Some natural sources include things like wildfires and also breathing. Like, right, we're breathing. But y'all, on a test, don't say that breathing is the main reason why because our population has grown, that we have so much CO2 in the atmosphere. Is that a true statement? Yeah, but think of all the extinction we've caused, right? Those are organisms breathing as well. So I think there's sort of a balancing that happens. But a lot of people will be like, well, it's just because we're breathing out here. No, y'all know better than that. It's the burning of fossil fuel. That's what's really causing the problem. Methane gas, same thing. We also have a release that's natural and some that are anthropogenic. So our anthropogenic sources are things like animal feedlots, in particular cattle. And we're going to say feedlots. And the reason is because if you looked at what cattle are actually doing, it's not necessarily a bad thing to raise cattle. If you're grass grazing them, it's really when we put them in a feedlot and that's all they do is they eat inappropriate food and they belch and fart a lot. That's what it is. All right, methane gas also has a couple of other sources. One is wastewater treatment. And that one is mostly, remember, from anaerobic digestion or anaerobic decomposition that this happens. So wastewater treatment. And then there's also landfills. Now, what can we do to help with those two things? Well, one of them that we can definitely do with landfills is we can stop throwing away our compostable materials. So yard waste, like sticks and limbs and those kinds of things, if we stop throwing them away, there's nothing for the decomposer to eat. Food waste. If we quit throwing away our food waste, we're going to have less amounts of decomposition that's going on in a landfill. The other thing is quit throwing away water in the trash. Quit throwing away your water. Put it in the sink where we can take it to the wastewater treatment. Now, what difference does that make? Well, the difference is that you're feeding the anaerobes. When they get to the landfill, if you've thrown water away in the trash can, they have now a water source, and that's going to speed up that decomposition. Here's the reality about landfills. They are tombs. That's what they're built to be, tombs to hold our trash. So let's don't put things in the tomb that's going to speed up decomposition. Then you're doing something. You're actually doing something for the environment. All right, now they can also, just an aside, they can also take that methane gas and burn it to generate electricity. And we'll look more at that in our next unit. So there's that. Now, in addition to our anthropogenic causes, there are also some natural causes of methane gas as well. One is termite mounds. And the other one is wetlands. Now, they both release methane gas, but if you look at the totality of it, we know that the one we really need to be concerned with are our anthropogenic causes. Now, methane gas, is there a lot of it there? Not in relationship to the CO2, but what do we know? We know that it is 21 to 23 times more potent than CO2. So there's that. Right. Now, these are both naturally occurring gases, right? They occur naturally in the environment. We've already talked about that. But they also have their anthropogenic causes as well. Now, the good thing is that when you have a natural gas, there's a natural process to deal with this. And those are dealt with through the carbon cycle. So there's up and there's down. And if we grab hold of how we can do that, we're better off. Okay, another one involved is nitrous oxide, N2O. And where is this coming from? This is coming from the overuse of fertilizers. All right, so what's happening? We're overfeeding the denitrifying bacteria. So it's denitrifying bacteria. But we're overfeeding it. All right, so that's causing more nitrous oxide to be released into the atmosphere. Okay, another one is our CFCs and HFCs, which are also called fluorinated gases. I misspelled that. Okay. Now, what are these coming from? What are the sources? The sources are things like refrigerators, air conditioners, blowing of styrofoam, aerosol cans, and what's the other one? Firefighting equipment. So there's halons there as well. Okay, so let's say solvents and pesticides. So we'll talk more about that later. Now, these are very, very potent, right? They're very strong gases. There aren't very many of them, and these are something that we can absolutely control. Here's the big problem. They are man-made, all right? If they're man-made, that means that there is no natural cycle to deal with these. So it's much harder to remove them from the atmosphere simply because there is no natural way for us to figure out how to do that. So the best thing we can do for those is just stop them altogether, right? We have to find replacements that don't have as long a life and are easier to remove. All right. There's some talk out there about how to replace our HFCs because we're not using CFCs anymore. And it's just tricky. There's a lot of processes that happen that use these gases, and how do we get rid of them? And that's really difficult to do, but they're working on it. All right. Let's see. Oh, one we did not talk about is water vapor, H2O. Excuse me. Hey, y'all, water vapor, the most potent of the greenhouse gases? Water vapor. Now, why don't we really address that? Because we don't really have anthropogenic sources for water vapor other than, I don't know, if you could probably tie it all in together. But here's the thing about water vapor. It's very short-lived, right? So it's going to condense and it's going to fall out really quickly. So it's really efficient at trapping heat, but then it's going to release heat as well. So if you remember that latent heat release effect, water vapor is definitely involved in that. And I'm going to squeeze one more in here in the middle. And I'm going to kind of blank it out since I don't have a lot of room. And this is tropospheric ozone. So remember, tropospheric ozone, it mostly comes from cars because it's a photochemical reaction between our NOxes and our VOCs. And both of those are released through driving. And ozone is a good trapper of heat. We know that because in the stratosphere, it's pretty successful in creating a heat layer, but in the troposphere, not good. All right. Also, remember, ozone is a big respiratory problem. So it's an air pollutant, and it's also a greenhouse gas. All right. I think that is probably it for the causes and different chemicals involved in global warming. All right. So the question here is what are the environmental effects, right? So the first one, the environmental effect is warming. All right, now warming can lead to a whole host of problems. So the warming means that we have an elevation in temperature. That is the first environmental effect. Now there are consequences associated with rising temperatures. And this is going to look really messy, and we're going to work our way through this because there are a whole host of problems that occur. So the first one that happens when you have elevated temperature is you're going to have more severe storms. So how does this happen? It happens because elevated temperature means that the atmosphere is going to be able to hold more water vapor. Well, it's going to draw up moisture from the ocean, and in the Atlantic, that starts that big spinning. It's called a hurricane, and it's going to start to spin those storms more and more. We talked about yesterday the fact that last year, in 2020, we had one of the very worst hurricane seasons of all time. And there were so many of these named storms that we ran out of alphabet. We had to start all over again. This is a definite consequence. And we also know that we have to mitigate for these things. And so those are going to be some of the impacts that we'll talk about here in just a little bit. Now, what do severe storms lead to? Well, severe storms can lead to flooding, and mostly coastlines. Now, it doesn't have to be coastlines. A hurricane can travel up into the middle of the continent as well. And so a hurricane can make its way up into landfall, way up into like Tennessee. If you ever track those storms, you'll see that they can track them with heavy rainfall as you go through. And what is this going to lead to? Flooded coastlines usually leads to destruction of habitat. And then what's that going to lead to? Well, that's going to lead, and I'm going to kind of put this down here. We're going to come back to this repeatedly. It's going to cause a loss in biodiversity. All right, so that's sort of the pathway that we're on. Okay, so that's one effect of warming. So let's talk about a couple of others, and I'll try to see if we can highlight these in a different color so we can see them a little bit easier. All right, let's move over to Warming temperatures. What else is an effect, an environmental effect? It leads to melting ice. All right, remember we have two kinds of ice. We have ice caps and we have ice sheets. And glaciers. All right, or we can also put in here land and ocean. We make the distinction because remember, ocean ice is already in the water, so it's not going to lead to a rise in sea levels. All right, what is it going to lead to? Well, it's going to lead to a change in ocean currents. And it's got a couple of them to remember are the Gulf Stream is going to weaken, and also the thermohaline current. Now, why does this matter? Well, when we talk about warming, one of the things that we think is that it's an even amount, right? But it's not. If the Gulf Stream weakens, what's going to happen is that the warmth that was brought from the middle of the planet, from the Gulf, remember the Gulf's like a big giant bathtub, and once that warms up and that water moves up, it actually is able to heat northern parts of Europe. If that weakens, what's going to happen? Europe is going to get cold for a while. The other thing is that melting ice is going to also change the way in which air currents move down as well. So ocean and air currents. So why did we get so cold in February? We can point back to the fact that the Arctic ice melting up there created this polar vortex that came through, and the strength of it is directly tied into the melting of the ice caps in the Arctic. Okay, so there's that. And what this change in ocean currents is going to lead to is basically a change in climate. That's just kind of it. Some places are going to get colder, some places are going to get warmer, some places are going to get drier, some places are going to get wetter. It's just change. All right, what about these ice sheets? This is the one where we're going to get to seas rising. Because we're now taking water that's stored on land and we're putting it down into the water. And that's going to cause everything to rise up. The big one here, there's two, Antarctica and Greenland are the big concerns. And then Greenland's got its whole problem with the thermohaline current as well. All right, now, what is sea rising going to lead to? This is where we kind of need to just go ahead and put ourselves a little arrow pointing up to flooded coasts. Right, sea rising, that's exactly what it leads to. Now, it also leads to, once it gets to the coast, it's going to also lead to saltwater intrusion. So the picture I showed you with those trees in North Carolina dying, that's the direct relationship to the rising seas. So what does the saltwater intrusion lead to? Destruction of habitat, just like that, which then leads to a loss of biodiversity. Off we go. All right. So they're also in the rising temperature, and let's see if we can make another change here in our colors. Let's go with purple. Whoops. All right. The warming temperatures, and I'm gonna put an arrow going this way because it gets so messy. All right. What happens here is that our oceans warm. So the warming temperature causes a rise in temps, which then leads to ocean warming. Oops. Now, remember, we are covered in over 70% of the planet in water. Now, so this makes a difference because what happens with water as it warms is that it starts to expand. So the separation between water molecules begins to expand. And this is known as thermal expansion. All right, so thermal expansion simply means that the space between water molecules gets greater. It doesn't matter in a little pot of water, like you're not going to be able to see it. But when we talk about the ocean, we're talking about a huge chunk of water molecules. And as that happens, as the thermal expansion happens, what's it going to cause? It's going to cause the seas to rise, right? Because now it's like the water has swelled. And as it's swelled, it's swelling up over the land. So it's not just that we're adding more water in, the water itself is expanding. And that's going to cause the seas to rise, which then, of course, causes flooding, which then causes destruction of habitat, which causes loss of biodiversity. So you get where this is going, right? That's where it's all leading. Okay, another warming effect is something that we talked about really early in the semester, and I gave you an example of what it means to have a positive feedback loop. So what was the positive feedback loop? We're going to take our warming and we're going to come over here and we're going to talk about melting permafrost. Now, a lot of people will say melting permafrost leads to rising seas. No! The permafrost is permanently frozen ground. Permanently frozen ground. It ain't gonna cause the seas to rise, y'all. It just means that the ground is gonna thaw. Now, why is this a problem? It's a problem because melting permafrost leads to decomposition. What kind of decomposition? Anaerobic decomposition. So all of that soil stored in the permafrost that's frozen is now thawing, but it's buried in layers. Layers are like an onion, completely buried. And so now the air can't get to it. So when it starts to melt, it's going to heat up, right? It's going to get warmer. What likes warmth? Anaerobes. What likes moisture? Anaerobes, right? So now what are they going to do? They're going to start decomposing. And so what is that going to create? It's going to create an elevation in methane gas. So we didn't really talk about it up here in the methane, but also melting permafrost could go up here as well. So that causes an elevation in methane gas. What is methane gas? It's a greenhouse gas. So now we have our positive feedback loop, because the more methane that you produce in a place like Russia and Antarctica and the northern Canada, you're going to have more melting occur, which then creates more methane gas, which then creates more trapping of heat, which then creates more melting. So we have a runaway positive feedback loop here. All right. And then there's one more that warming leads to, and that is, and this will be the last of the environmental effects that I'm going to give you. The warming temperature is going to lead to, oops, what's that? What's that? How do I get rid of it? Do that. Okay. The last thing is that warming leads to ocean warmth, and also the elevations of CO2 are going to lead to ocean acidification. And what is that going to lead to? It's going to lead to the collapse of coral reefs. And what's that going to lead to? Destruction of habitat, loss of biodiversity, just like that. All right. So, my goodness, that's a lot, right? So, when people are like, well, it's not that bad, really? This looks pretty bad to me. It affects everything across the globe. It doesn't matter where you are, you're going to be affected by this. Now, here's a problem we have in the state of Texas when it comes to this issue. And I get it. I've lived here my whole life. I know why this is a problem. We live on the prairie, right? If you think back to our climatogram, right? We saw that we always have an elevation in temperatures in the summer. It gets hot. There was back when they first started settling Texas, before this whole global warming started, Texas had a reputation for being hotter than hell. In fact, people would joke and say, you know, I'd rather go to HE double toothpicks than go to Texas. Because it's hot. It's hot in the summer. It's always been hot in the summer. We get that. We also know, we have a joke that says, if you don't like the weather, wait a minute. So we've seen ups and downs, and we say, well, that's just a natural part of it, right? We see this happening. But even if you looked at our temperatures, we are seeing that our hottest hots are getting hotter. Like, just simply, if you could chart this yourself and see that over time, that elevation in temperature is growing in the summertime. It also means we're not cooling down like we used to. And so, you know, what they did just yesterday or this week is they issued a warning that we could lose our power grid again this month. What? You know why? Everybody flipped on that air conditioner because we got warm. And they're like, no, don't do that. Don't do that. We don't have the power back yet. What are we going to do in August, people? What's going to happen? And this is a big concern. Now, we also have periods of drought and high rains. We've always been like that. But when you look at the amounts of drought, we've actually had longer periods of drought, and they're coming in closer intervals than ever before. So I know people don't want to hear this, but it is what it is. It's going to affect us. Why is California so far ahead on this? Because they have seen the direct impacts of all this. Wildfires increasing, temperatures rising, droughts increasing. And so what's happening in California is just a little taste of what we're going to see here. Okay, let's move on and talk about human health effects. All right, I'm going to lighten my color up just a little bit. How is this going to affect us as humans? Well, as our temperatures increase, this is going to cause a whole host of things. We're going to see an increase in heat-related deaths. So is this a big deal? Well, in the South it is, because we're so reliant on air conditioning. If our power grid goes out, we're going to see heat-related deaths increase. And it is a deal. It's a thing. All right. Another thing that we will see is that as temperatures increase, we're going to also see an increase in tropical diseases. All right, and this is around the world. So remember, diseases like Zika, dengue fever, West Nile, they rely upon mosquitoes, even Ebola. Not Ebola with mosquitoes, but those tropical diseases, they like it warm and they like it wet. So, one of the things that I just read yesterday is that they have genetically modified mosquitoes and they're releasing those into, into the environment in Florida this week that are going to be resistant to carrying dengue fever, which they've had some instances of, but it's really a problem in the Caribbean. So, especially if you're talking about an influx of flooding. So if you have flooding going on, that means that places are wetter. What likes to live in wet things? What likes to bury their eggs in puddles? Mosquitoes, absolutely. So mosquito related deaths, malaria, Zika, dengue fever, all of those are reliant upon that flooding, right? So there you're going to see a lot of increase in that. We also are seeing more waterborne diseases. Another thing is that flooding leads to water contamination. Which then is directly related to an increase in waterborne diseases. The other thing that you might think about is the fact that we have stronger storms, and those stronger storms carry with them an increase in death. We'll just skip right to the death part, right? So we're just going to show that we're going to have more deaths occur. But it also is going to lead to, and floods, so in combination, it also can lead to human displacement. Which simply means that people have to move, right? They're going to move. So when they move, they're going to move inland, probably. Although, one of the things they're showing is that coastlines that are flooding, people who can afford to move are moving away. The housing prices in those areas are dropping, which then means that more poor people will be able to move into those places, which means they're more vulnerable. They're more vulnerable to the flooding simply because the rich people can afford to abandon those places. So once again, we put poor people in a disadvantage. All right, so but human displacement can lead to overcrowding situations. So they're going to move inland to different places, and at that point, it's going to cause an increase in stress. And plus moving is stressful, and an increase in diseases. Why? Because we don't socially distance like we should, and so we're going to find an increase in those things. Okay, so what are the? Can y'all think of any others, by the way, that might happen because of this, like from a human impact or health impact? All right. Let's move on and talk about an economic impact. So, if we're losing land, right, it also means that we are losing our ability to grow food. So, we're going to find a decrease in arable land. And one of the reasons is desertification, right? So, our land is becoming less arable. And what is that going to lead to? That's going to lead to an increase in food prices, food cost. Also, flooding. What does that bring about? Well, it brings about things that need to be fixed, right? So we're going to find that we're going to have an increase in infrastructure cost. So things that need to be fixed are going to cost more, which then leads to a rise in taxes. Because everybody's going to be relying upon the government, whether it's a national government or a local government to or state government to try to fix these problems. We also find that our healthcare costs are going to increase. Insurance rates are going to go up because no one wants to insure flooded properties. Also, loss of jobs, right? So we're going to lose jobs. And these jobs could be anything from fishing along a coastline. If you lose our coral reefs and our estuaries, those are no longer going to be productive, which means that we also lose food from that end as well. Those are relying upon jobs, and so we're going to lose those. Also, if you were living on a coastline and you have to move, all of a sudden everybody's competing for the same kinds of jobs. So that can be a problem as well. We're also going to lose property value. In some places, so the property value on coasts is going to go down, but we're already seeing this happening. We also see an increase in property values inland. And Dallas is a prime example of that. We are already seeing our housing prices soar because people are wanting to move here. Because we said, bring us your tech, bring us your jobs from California, bring us your Amazon, bring us your Tesla, and we'll find a place for you, right? Bring us your Toyota. We'll take it. And now we're all competing for house prices. So if you're selling a house, good for you. If you're trying to buy one, Well, if you sell your house, you're probably going to have to move somewhere else. So that it creates all kinds of issues. All right. So another thing that we've seen with storms and flooding. So when you have an increase in storms, you're going to see that you're going to have an increase in things like looting and crime. Those have soared in places where they've had a lot of flooding happen. All right, legislation. There's two that we need to address. One is called the Kyoto Protocol. This one's the one that's in your textbook because of the age of the textbook. The Kyoto Protocol was signed in 1997, but the U.S. didn't sign. Why didn't they sign? Bill Clinton left this on his desk unsigned. It wasn't that he didn't agree with it. He absolutely agreed with that it was something we needed to do something about. But the problem is that he knew it wouldn't pass Congress because the tide had already turned against addressing global warming by this point. So he didn't sign it, and we were one of the few large countries around the world that did not sign the Kyoto Protocol. However, one came along in 2016 called the Paris Agreement. And this was 2016, and we all signed up. Now, there's a lot, if you remember from before the flood, there's a lot of controversy over whether the Paris Agreement goes far enough, whether it punishes countries for signing up for it, and all kinds of things like that. But as they address, it's baby steps, right? It's about at least getting started. Now, the U.S., one of the arguments that they make is that we don't need no stinking international agreement. We're doing just fine all by ourselves. And yes, we are making great strides toward using less fossil fuels, cutting our emissions, going toward vehicles that are fossil fuel free, things like that. So we are making steps. Our fuel efficiency has grown dramatically. However, as we know, this is an air problem. So what's the problem with air? The problem with air is it travels and it moves. If we fix it, it's not good enough. Also, remember, we have to hold people accountable for something. China is also making steps, but remember, they have become the manufacturing center of the world. If we don't address their consumption and their emissions, we are just as responsible, because that's where we buy all our stuff. They're making it for us. So an international, my opinion, I'm just going to say this, an international treaty and an international agreement makes the most sense, because we're a global economy. We are not our own little thing out here. People don't like to talk about this sometimes, but it's just the reality of it. We are all in this boat together. And that's just kind of the way it is. All right. So that is all, and I'm going to take a break and stop the video right now, and then we will continue on here in just a second.